We've seen what happens in a circuit when resistors are connected in series. Now let's look at what happens when they're connected in parallel. Now, parallel literally means that the resistors are parallel to each other like this. As far as the schematic goes, if we were to connect the top of both resistors and the bottom of both resistors, you have to keep in mind that although this node looks like it's in a geographically different position than this, since this is a wire, this is all the same node. And same thing down here, this is all the same node. So that means that the potential difference between here and here is going to be equal to the potential difference between here and here. Now, if we connect a power supply to this, let's just say we put one here and we connect it in parallel with these parallel resistors, now we have a very basic parallel circuit. Now, a consequence of this orientation is that both of these resistors are connected directly to this power source, so we can call this Vs. So that means that if the top of this resistor is connected to the top of Vs, the bottom of this resistor is connected to the bottom of Vs, then actually the voltage drop is going to be the same as the voltage drop here. So in this particular case, this resistor, the voltage drop will be Vs, and this resistor will also be Vs, because this top node is all one node. So generally speaking, the voltage of resistors in parallel is going to be the same. So that's really the main idea about parallel circuits, is that voltages of resistors in parallel are the same. So if you remember, the current in a series circuit everywhere is the same. The voltage in a parallel circuit is the same for if we have resistors in parallel like this. So let me kind of show you an example to illustrate that idea. Suppose we have a circuit that looks like this. Maybe we have a resistor here. We've got resistors in parallel there, and then this is in series with another resistor, and then that goes down into something like that. All right, so suppose this is looking into the terminals of a circuit. This can be R1, let's let this be R2, R3, R4, R5, R6. Okay, so in this orientation, the resistors that are parallel are R2 and R3. So here's a shorthand notation. R2 is in parallel with R3, so that implies that the voltage drop across R1 is equal to the voltage drop across voltage drop across R2 is equal to the voltage drop across R3. Okay, so same story here with R5 and R6. R5 is in parallel with R6, so that implies that the voltage drop across R5 is equal to the voltage drop across R6. Now, R1 is not in parallel and R4 is not in parallel. These guys are in series, but this R2 and R3 are in parallel, R5 and R6 are in parallel. So therefore we know that if we find this voltage drop, we therefore know this voltage drop, and likewise if we find this voltage drop, we know this voltage drop.